Math 21, I had a question coming out of section 7.3, number 37, and we need to solve this nonlinear system of equations. And you could do this a couple of ways. You actually, looking at it, I'll just highlight this for a sec. You could use elimination because I see there's x squareds here. So maybe I multiply this equation by -1. I'm going to opt to use substitution. All right, but I just want you to hear you could use either method. So when I take a look at this, I notice that I can solve this second equation for y, and then I can substitute it in to the first equation. So if I just subtract the x squared over, I'm going to get y equals 1 minus x squared, and you see that here, right? And then what I'm going to do is I'm going to substitute that expression into y squared and also into y, in the first equation. So I actually, now that I'm looking at this, I got to remember to substitute it in there as well. And so that's what you see me doing, right? So instead of x squared plus y squared, there's my 1 minus x, but I have to remember to square it, and then just 1 minus x squared there. So then when I start foiling things out, and let me go ahead and show you this. When I take 1 minus x squared, right, that's 1 minus x squared times 1 minus x squared. When we do first, outer, inner, last, and I simplify that, I'm going to have 1 minus 2x squared plus x to the fourth, and that's what you see right over here. In this one, I distributed the -6, right, and just take note that sign, when I did -6 times -x squared, I had positive 6x squared. And then I'm going to go ahead and just simplify this whole thing. All right, and so when I go to simplify that, I'm going to be left with x to the fourth plus 5x squared minus 12 equals 0. And it's not quite a quadratic equation because it is a degree 4, right? But the thing to notice is that this, right, degree 4, and this middle term is degree 2. So since it's half as much, it's in quadratic form. And what I can do with that is, instead of using the quadratic formula and solving for x, I'll use the quadratic formula and solve for x squared. So I'm going to roll with a equaling 1, b equaling 5, and c equaling -12. I could also try and factor this. It's just there's nothing that, and let me get my highlighter up for this, there's nothing that multiplies to 12 and adds to 5, so you kind of get stuck. All right, so if these are my coefficients in the quadratic formula, and again, keep in mind, and I'm gonna highlight this, I'm solving for x squared. I'm gonna have x squared is -b plus or minus b squared minus 4ac all over 2a. And when I simplify that, right, keep in mind this is x squared, that's what I'm looking at. I'm going to square root both sides, and then the plus or minus will show up. And that's what you see here. All right, so now I've solved for x squared, and then when I square this, that's what I've got, okay? Oh, and actually, let me back this up. When I had my 2x squared equations, I should say, when I tried to square root both of these, I had some non-real answers. So I have, right, -5 plus the square root of 73 over 2, and -5 minus the square root of 73 over 2. And this one here is a negative number. So when I ultimately try and square root that, I get an imaginary answer. So it doesn't give me any real solutions, which is fine. So ultimately, these are my two answers, okay? So then as I start to solve this, keep in mind, if we go all the way back to the front, and I'm going to circle this, right? We know y is 1 minus x squared, right? So I'm going to take these two answers and now sub them back and get my corresponding y coordinates. The nice thing is when I actually do square this beast, the square root will go away. It's still going to be a little ugly, but I can make it work. So as I head down here, right, I have my two possible answers, the plus or minus that square root there, and then I'm going to sub them, right? So you see me subbing them in right here. When I square that square root symbol goes away, and I'm only left with the radicand, right? And then I have fractions, so I'm going to get common denominators. Keeping in mind, I'm going to distribute this negative, so a negative of -5 is positive 5, and a negative of positive square root 73 is negative square root 73. I got my common denominators, right? And then when I add the numerators, just keep in mind, right, we keep these denominators. This is going to be 2 plus 5 minus root 73. These are like terms, so I have 7 minus root 73 over 2. And I get that regardless of the plus or minus, because both positives and negatives are going to square to a positive number. So I have these as my 2 ordered pairs. Those are the exact values, and I could plug those into my calculator to get the decimal approximation. All right, thanks so much. Bye.